thank you for attending this session on Ask Tom on JSON. And today we're going to cover the database API for MongoDB. So this is a brand new feature, and I don't want to bore you with too many slides. So the majority of this presentation will really be demos. And we have a bunch of guys who are actively working on this project here on this talk. So we will also have some questions later. So feel free to ask anything you want. Good. So what are we going to cover? I will speak a little bit on the database in general. Most of you are probably very familiar with the Oracle database, but I hope we also attract a few people that are new to us. So we'll briefly cover the database part, then we will demo the API, and we will have enough time for questions. So the Oracle database has been around for quite a while, and it is what most people would call a relational database, meaning it supports primarily tables and columns and joins and transactions. But over time, over the last many years, multiple other data models were also added. For example, XML was added, or full text search. We can do spatial data processing. And among those, there's also support for JSON. And we actually added all these JSON capabilities to the OpenSQL JSON standard. So now we see many other database products also adopt the operators that we invented many years ago. The main idea, or the good part of this Converged database, is not only to have a database that supports all these different data models, but that it's also able to convert data in one representation into another. So what we see a lot with JSON customers is, for example, that they store data in JSON format, but they want to do some of the processing relationally. So what they do is they create relational views over their JSON. Or similarly, in the other direction, we have customers that have relational applications and they want to generate JSON data from that very same data. So it's really the ability to handle multiple models and to convert data from one model to the other. That is a huge benefit of the Oracle Converged database. And we have some cloud databases. So the Oracle database is available on what we call on-premise. So you can download and install the Oracle database on your own machine. Since a few weeks, there's actually the Express edition out there. So that's a free database you can download on your laptop and work there. But we also have what we call autonomous databases. And this is the Oracle database in a cloud offering. And we have different variants of it, which are optimized for specific workloads. For example, we have a service for data warehouse or analytical queries. So this is where the database is primarily optimized for this kind of workload. And we have databases for transaction processing, and one that's even like dedicated for JSON. It is pretty much the autonomous transaction processing database offered at a lower price point if you primarily work with JSON data, but you can also work with relational data in this autonomous JSON database and upgrade to the full autonomous transaction processing database at any point. So the benefit of these cloud databases is not only that they are optimized for a specific workload, but that they are also automatically perform things like patching or optimization. So it takes a lot of the DBA work off and automates this in the cloud. So it's a lot less maintenance to work with an autonomous database in the cloud. And for these three autonomous cloud databases, we offer a new service, which is the Oracle Database API for MongoDB. And this is what we're going to cover today. If you want to give this a try, for example, you don't have to spend any money to get access on it. We actually have something that's called the free tier. So you can go to Oracle.com Cloud Free. You would sign up there. In some cases, it asks you for a credit card, but it would never bill you. And we also do some events like the Database World in a couple of weeks, where you actually, if you sign up for that, you get typically whitelisted and you can skip this credit card part. You would also get some credits, but they're actually not that important because we have an offering which is called Always Free. So once you've signed up with Oracle Cloud, you can run 2 databases entirely for free. So this is not a trial that expires after a few weeks or months, or you get some credits and once they're gone, you lose access to it. No, this is really always free, because once you sign up, you can work with these databases always for free. Obviously, they will be limited in terms of amount of data, and you won't get that much CPU, but it's definitely sufficient to get started and try out something. So I really encourage you to get like a free cloud database here. Good. Now with this, let's get to the database API. So what is this? What is this new feature doing? And it's you could summarize it as the goal is to use the Oracle database as if it was a MongoDB. And I put like with limitations on here, so we're very openly speaking about what we can and what we cannot do yet. And I will speak to that in a second. But the important part is this is not some sort of replication scheme or mechanism where we sync data with a MongoDB. Instead, it's a true connection from your MongoDB client or tool, etc., to the Oracle database. So you can do read and writes in both directions, and this is what we're going to show in a second. Now, if it comes to limitations, there are a couple, and I'm explicitly listing out 2 here. One, for example, is that we don't support MongoDB's user model. It is just different to Oracle's, and we believe that most Oracle users are familiar or like the way that we deal with users and roles and grants, and it would be quite confusing if you had a different model there. So if, for example, you had an application that made extensive use of MongoDB's user model, then most likely that wouldn't work out of the box. And the other limitation that we have at the moment is, for example, we don't support MongoDB's aggregation framework. And one reason is that SQL is just a nicer way to express your analytical queries, for example, for reports. And the reason is that in SQL, you write declaratively what you want and you leave it to the optimizer to pick the best execution plan. So you don't write a pipeline or a sequence of aggregation functions that are executed one after the other and potentially could do it in a poor order or in a poor performing order. Instead, SQL is more performant typically, and it's also a lot less verbose. So for now, you would have to write SQL if you wanted to do some analytics over MongoDB collections. Why did we create an API? Like, why did we create the ability to connect your MongoDB application to Oracle? Well, there's 2 main reasons. One is that there are a lot of developers out there that have skills that like to work with this API. They may have existing code. There are a lot of drivers out there, frameworks, etc. So those could use the Oracle Converged database and especially benefit from the unique and added advantages, like really powerful SQL capabilities. And obviously, it would also make migrations easier, as you can run mongoimport or Mongo restore commands to move your data. When is it available? When is it available? As of today, it's available in what we call a limited availability mode, which means it's only in some regions and it's not enabled by default. So if you want to play with this, it's very easy. Just write an email to rogerford@oracle.com and we will give you access to it. So we can either enable your existing cloud database if it's in the right region, or we can tell you how to set up a database, also always free, in the right regions. I mean, the regions are growing. Right now, I think we have 3 regions or 2, but more regions are coming. Good. So now let's go to these demos. The demos are basically 2 parts. One is rather high level, just giving you some concepts. We will use Mongo Shell, MongoDB Compass, SQL Developer Web. And after this, my colleague Loic will do a deep dive showing like a Mongoose migration and how you can really make use of the Converged database benefits in terms of spatial, SQL analytics, machine learning. And this is a live demo, so things may go wrong. Apologize in advance if something doesn't work out of the box. This is not a pre-canned presentation. And again, if you feel you want to give this a shot yourself, just email to Roger Ford and we'll happily work with you to get started. And we're also very interested in hearing your feedback once you tried it out. So this is really an opportunity right now, let's say for Oracle ACE directors, etc., to be among the first to try out this new feature. Good. And with this, let's get started. So what I have here is just my regular shell. Let me move this away. I hope you can still see this colorful screen here with a Mongo shell, right? Like, do we still see this? Everything is quiet. I hope you guys are still there.
Yeah, we can see it.
And let's start my Mongo shell. And this is the regular Mongo shell command. So now I'm using one of MongoDB's utilities here, and I can say show collections, and it would list me some collections that exist on that database. And now it is not connecting to like a MongoDB server, but instead it's connecting to one of our autonomous databases here. So now I want to create a new collection, and I give it the very nice name test123, and I get back the typical result that the collection was created. Now, if I do show collections, we would see and if the collection was added. And let's add some data here. You all know I'm a fan of Tintin or Tintin, Tim und Struppi in German. So we insert two documents here, like very trivial JSON object. Tintin is a journalist and Haddock is captain or a retired captain. If I do a find, I see these things. Let's do an update here. We want to add some information. So we want to update our Captain Haddock and give him a hobby. And you all know what, if you know Tintin, you know what Captain Haddock likes to do. And we see we added his hobby here. So what did I do? I created a collection. I inserted some JSON data. I did an update. And now let's go to the SQL developer web here. So this is our web console to our cloud database, our autonomous database. I click refresh here, and I hope I see the new collection, test123, and it is basically mapped by a table. So this, if you're familiar with what we did in the past, this looks very much like a SOTA collection. So we map JSON collections to a table. There is some housekeeping column, like when was this created, an ID column, and something called JSON document. And this is where we store the JSON data. So I can run a JSON serialize, and I see the data I just inserted. I can use SQL over it just to extract some fields like the name and the job. And let's even do an update here. So we know that Tintin practices yoga. So we make this the hobby of Tintin. And let's go back here and do a find. And we see Tintin's hobby was added here. So I was able to basically also make changes in Oracle database, and they're immediately visible here because it's accessing the same data. Again, it's not a replication scheme. Okay, so I'm not a big shell guy here. Let's use another tool. And this is MongoDB Compass. Using a similar connect string, I'm connecting to my Oracle database. Let's see if this works. Sometimes it does, sometimes it takes a while. Okay, now we have our admin user here. We see our test, but let's create another collection. And here I actually found some sample data that people use when working with MongoDB. And it's some movie data. And okay, where's this one here? And I have created now this movies collection. It's empty, so I want to import some data. And This is the data I downloaded. Got a bunch of movie data in here. So this will take a while, not really because the database is so slow, but rather because my upload speed is quite slow. So I'm sitting here behind a Wi-Fi repeater, and I think Josh tried it out and he said it took him 7 seconds. Like mine will take a little more, but we should be seeing a movies collection here quite soon. If I refresh again, it's the movies one. It looks the same, and we are going to do some operations on movies. So the count here, 11,000 inserted. Okay, good, perfect. So let's do another count. We should see a few more. It's 23,000 movies, and I can do a JSON serialize, and you see that this is how the data looks like. And what I can also do here is I can project this out relationally. So what I do here is I want to view my data as if it was a table. So this is a relational mapping using the nested clause where I extract the title, year, and a field called cast. And you see cast is a JSON array that contains all the name of the actors and actresses. And the way it's represented here as an array makes it hard to do comparison because I don't see the actor and actress's name as separate values, but I can quickly do that if I do another level of nesting where I also unnest the cast. So now you see that the movie names get repeated, and I do see the actor names as separate values. And obviously this will increase the number of rows because I generate rows for every actor. Good. So now in order to not have to write that query all the time, I could hide it against a view or a materialized view. And now I can, for example, directly query that view that I called title actor map, and this long query is just hidden now after the view name. Okay, so what I could do now is, for example, I could find how many actors or which actors are most active by counting the number of movies they play in and order it. So I see James Franco is the most active actor here in this range, in this set. I looked at more recent movies after 2010, because a lot of movies start at 1915 or so. Good. And what I could also do is I could generate new data. For example, what I have here in this data set is I have many movies, and every movie has an array of the participating actors and actresses. But what if I wanted the opposite? What if I wanted the actor name and all the movies they play in? So this is what I use in this query here. I am selecting from my actors view, and I generate a distinct subquery. So basically actors is all the distinct actors. So every actor name only occurs once. And then I generate a new JSON object with the actor name as a field actor, should be actress or actor. And movies is a JSON array with all the movies that they play with. So I generated this, and you could consider that this is a report over a MongoDB collection. You could also add joins here if you had multiple collections. So again, let's create this as a view, which makes it now a lot more compact to access it. So select star from report gives me this. And what I also did is I injected like an ID field here. This is what MongoDB wants. And now I could add this to a new collection. So this will fail. There is no collection called actors. Let's quickly create one. So what I do is db create collection actor. There it is. Now this insert should succeed. And the goal is really to...
you had actor rather than actor when you created the collection.
Okay, I'll correct it here. See, this is good. Everyone sees this is live. And now what I can do here is I could query it. Was it like db actor find So now I see like new data that I just generated. I see that Elizabeth Banks played in this movies, and obviously I could also run a QBE. Let's give this a try. Actor find. What is it called? Actor and Arnold. So let's see if this works. If there's no typo, it's a long name. Base is up. Let's restart the Mongo shell and run the query again. Now it worked. We'll look into that, but you see I just restarted the Mongo shell. I don't know what the hiccup was, but now you see that we were able to do a find by this query, and we find the stuff. Okay, took me a little longer than planned. Sorry, Loic. Now it's your turn.
Yeah, thanks. So I stopped sharing my screen. So hello, everybody. I'm very happy. This is my very first custom office hours today. So I'm very pleased to take part in this new announcement. So this is a very new feature. And so today we will deep dive into what we can leverage with this API. So taking the position of MongoDB developers and discovering this brand new world. So for this, there is a demo. You've got the code available on GitHub. You can start it. Thank you in advance. And let's go for the use case. So today, what I just want you to think about is, what about these new kind of use cases where this trendy technology which is called machine learning will be used to anticipate machine failures. So this is called predictive maintenance, and let's get through the use case. So typically we'll be based in USA, and we will have to work with 1,400 plus metalworking machines, and they will send every 10 seconds the data coming out of their sensors. On the business side, what they want really is to anticipate machine failures, because it costs a lot to repair, and as well in order to manage appropriately their on-site engineers. They want to add a real-time dashboard, highlighting the different failures, of course, on a map. So this will give you this at the very end of the demo. So first of all, let's introduce some kind of simulator, because I will not use real sensors. And so I've written an application using the JavaScript language, the Mongoose frameworks to access MongoDB database. It's running on a Node.js VM. And so it should be very common for any MongoDB developers with this environment. And so we will just show very quickly how it works going inside the IDE. So this is Visual Code Studio. You can see that there is some code in JavaScript, and very quickly you can see that we have enabled right here the debug mode for Mongoose, so that you will see clearly what happens while the application is running. You will see the commands being sent to the MongoDB database. And so what we will do next is see the MongoDB connection string. So this is a very typical one with a server in the OCI cloud. And we will access it very, very easily. So if I go using MongoDB Compass here, you will see that there is just one collection today. There are some data inside it, and we have typically stored the list of the devices we are looking over. And all of these devices have an IDE, the ID machine. They are based in some places, so it's in USA, but in some state, city, and we also have some GeoJSON encoding here. So let's launch the loader here, and what you will just see that it will start connecting to the database, the MongoDB database, find the existing devices, and then it will start inserting data over and over again every 10 seconds. It will use statistics, a collection named statistics, in which we will store, let's say, the information about what we just did. So we start with no data inside it, and then we will just insert using bulk inserts data inside the device metrics collection. So a third one, and we will just insert as well where we are in terms of loading the data here. So we have processed this number of documents so far with the insertion speed of this number per second, right? We can see the bandwidth being used as well. So I'm at home using Zoom, and so the bandwidth is not necessarily optimal. But let's go into more description of the use case. So as I said, it's using the Node.js VM. We have seen that MongoDB Compass is being used, and everything is fine so far. So what I will do next is to show you a very quick migration of these data sets onto the Oracle database, so that you will see how easy it is. But first of all, why do you want to migrate to Oracle database? So there are some good reasons. We will present some of them today. They are not exhaustive. We might find a lot more reasons for doing so. But anyway, what we consider today that MongoDB is really a single model database. Whatever you read everywhere, it's really, from a persistent perspective, it's JSON and BSON format at the very end. So for example, if you want to process your data or do something else much more advanced or use other technologies today, it's kind of unsupported today with MongoDB. So you can, of course, index some documents, you can do full text indexing, for example, but you can't put inside it, let's say, PowerPoints or PDF and index them. So that's what I mean by full text indexing. If you want to work with relational data, this is the same thing. You want to use another database side by side with MongoDB and do some data wrangling outside with other tools. Machine learning is another typical scenario, graph processing as well. So typically, you need to pull at some point your JSON data outside of MongoDB and process it outside and potentially put it back there. Other typical situations where, for example, you want to have more security, you may rely on the Oracle database state-of-the-art security, and you can look at what we have in the maximum security architecture. For availability, that's exactly the same thing, and we had moreover about data protection. So there are much more to dig into these different areas, but I will not have the time for this today, sadly. But some of the requirements to migrate to Oracle are clearly, these are the top three, I would say. So let's go for the migration of this data. So first of all, we'll see that we go from the left to the right. And what we do today is really, because these are very small data sets, we will just use common tools like mongoexport and mongoimport. So let's go on the VM where actually the MongoDB database is running. And you can see that I will just need to run a mongoexport shell. It will just drop the different devices into some collection, right? Into the devices.json file. And now I can just import and target the autonomous data. So I will show you as well, like beta, that today there is in my schema no devices collection, right? There are some already existing, and I will explain that just in a moment. So now we're just running the import, Mongo import tool. You can see inside it that it's really running the Mongo import, right? So Mongo import, right? Just so that you can see Mongo import here. And so what you can see here, we have just uploaded this number of documents. So let's see how this gives. The collection is there, and we can access it throughout the JSON document collection as well. So it's just a pure, it's kind of equivalent to MongoDB Compass, but you can just work without doing SQL, for example. So let's go back into the SQL dashboard here. So as you can see, we have just made the Mongo export, Mongo import, and then we just need to stop the application, which is still running, right? And I will just switch the MongoDB URI, right? So screen and starting again. And what you will see here is that, remember, no statistics collection, and can believe me, the collection device matrix was empty. And as you can see, we are performing exactly the same code. We are running the same kind of queries or single inserts, find one and single insert one here, and bulk insert there, and it's doing exactly the same thing, uploading data right away. So now let's go on this. Just I wanted to precise something, so maybe that's interesting to see how the relational world can be used to enhance and improve the JSON world as well. So what I did, for example, the device matrix you've seen did exist just before. So what I did is just use some default MongoDB collection, and then I just partitioned. I did partition the collection. So it's very interesting because you can see that doing so, we can have a proper data management. So for example, if you want to merge some partitions, or if you want to drop them after, let's say, 1 week, you can do so. Again, another common thing that you can do is just creating indexes, right, onto your collection. So here, this is a concrete index on a relational kind of column and a JSON field. It's local to each partition, so you can see that every kind of feature like this can be used to improve performance, for example, here. So let's go on with the use case, because we are just starting. So Bida explained that as of today, we consider that the aggregation framework is really a great idea, right? But migrating to Oracle world gives you a great opportunity to innovate, meaning to use the powers that SQL can bring you today. And yes, aggregation framework, because you don't support the SQL engines and the optimizer behind it, that's probably the reason it's had to do that. So having analytics on top of JSON is very common use case. So just to remind you what SQL can do for you today, first, SQL is everywhere, right? You have the skills, you learn that as in school, you have the tools, the frameworks, and it's supported by the whole IT community, I would say. SQL is a standard, so, and that's why it's really so popular. And it is continuously evolving. If you are very curious, you can see that inside the latest standard from 2016, you have a lot of JSON operators that Vida already presented just before. But it is also SQL. What I like about it is it is extensible. So you can write your user-defined function using PL/SQL language and even JavaScript today, and more to come. You can use SQL macros for the one knowing these latest features. That's very, very interesting. If you don't know about SQL, and I know it can be cumbersome to learn initially, but believe me, that's really really easy. And it takes maybe just some days to be very fluent with SQL. But in the case, you can use, for example, tools that you can build. So for example, there is this aggregation pipelines translator that you can just use. You give it the pipeline, some JSON document as an example, and it can translate that into SQL. And I will just show you the process of doing so manually, for example. So not for the experienced ones, but maybe just for newcomers into the Oracle world. So let's take this very basic aggregation example, where you will see that we will initially retrieve documents from the devices collection here. So we are using the from and select keywords, and then we are leveraging the SQL dot notation so that you can just figure out which JSON field and accessing them one by one, I would say, in order to do more things. So you can display them using the select statement, but also you can create groups using the group by keyword, right? After that, you can use aggregation functions. So here I'm just counting the number of documents for each group. And then I can, if I want, filter out each of these groups, for example, those who have less than 50 installed machines. And then I can sort the data using the second column here, so by count, by number of machines installed, and I can just keep top 3 US states where you have the most interesting number of machines. So let's go for just doing so here. So kind of what did I do, but let's say you will learn maybe two more things. So going back and forth from JSON to relational and from relational to JSON as well. So let's start very basically to see what's inside our collection. And so as you see, that's a common kind of soda collection, but much more inside the MongoDB world. You can just serialize your documents, so already done as well. But you can, what Bida didn't told you is that you can beautify it, right? Here it's just one row, but if you want to make that more pretty looking, you can just use a pretty keyword. And there you can have formatting of your data. Let's put that a bit large. Yeah. Then an interesting aspect is there is in each collection an ID. So this is the primary key of the table mapped onto the collection, the JSON collection. But here you can see that we have made the effort to just replicate the ID from MongoDB into this column and primary key. So you can have both information and it's exactly the same thing. Then using that notation, you can read different things. You can sort your data. I will do that here. You can group by exactly the same thing. So for example, grouping by state here, right? And sorting by the number of machines present in each state. And then I can just filter out so that I have less than 50 machines installed, right? So far less here. Next, you can see that I can do the top 3, but more interestingly, I can build back JSON documents right from this kind of relational data. So here, typically, putting that into some documents, I can build an array with these documents. But here's the tricky part is that it will build one array with one document inside it. So that's not necessarily what I wanted to have. But then I can look for more complex example using a common table expression. And then I will just use the previous results and insert it to build a JSON array aggregation. So here, just running the query and I get exactly what I wanted. For example, an array of JSON documents sorted by the number of machines top 3. Right? So that's basically how you learn. And so this code is available on the GitHub repository. So feel free to use it and to learn from it. So next, we'll deep dive into more interesting things. So let's continue to load our data. Great. And let's improve the application. So far we have just kind of ported the application to the Oracle world. And so what we will do now is to look at these unique advantages, right, that we spoke at the very beginning of the session. So we are speaking about today improving the application because we will add very interesting features. So let's talk about these machine learning things, right? So I will not show you the full experiment, but know that when you have your autonomous database, it comes with a lot of interesting features, like, for example, the ability to have notebooks and machine learning models being managed internally. So what I will do next is very quickly load some data, right? We have these on-site operators that have just written into some Excel sheets information about machines. So you can see each machine per line with these different values of their sensors and an interesting column here where it's meaning 0 when the machine just failed with this values frozen sensors, not failing, false, or 1 when it was failing, right? So this one was failing with these different values. And so what we'll do next is really to use this data. So I will load so I will just load some data, and very quickly you will see that it will be imported into the Oracle database. So just choosing this sheet here. I'm just trying to show you much more than just what you can do with some command tools, right? So just importing my data, and it will create me a table very quickly named original data from the name of the tab inside Excel. And I will use it. So it's basically here, right? And you can just quickly query it like this, select and apply. And here are data from the SQL, from the Excel sheet, sorry, inside my database. So some seconds to do so. And then we can go into these tools where we will create an automatic machine learning experiment. So the goal here is really to train a model from my data without extracting them. And to do that, we'll just leverage the AutoML capabilities. So predictive maintenance, right? No comment. And the data source I will use to train the model is this brand new table called original data. I will try to predict the value of the failure column. So I'm just selecting the failure, Boolean, so true or false for the prediction. So you see that I've already some classification family to being chosen for me. And I will just select the unique identifier for each scale, which is the ID machine. So next I will clearly use more power auth. We still use balance accuracy. I can deselect some algorithm, but they have already been chosen for me. And what I can do so not using this, for example, or not this one as well. And I will then just use the proper features. So we'll just keep every kind of sensors, removing the location, for example. Longitude, just remove that. First name and last name of operators, I don't care, and the status. So here, all my features have been selected, and I can quickly run the experiment. So running the experiment, it will use the notebooks and try to train some machine learning models concurrently. It will do automatic preparation of my data. It will select the proper hyperparameter for each of the algorithms. And at the very end, I will get some algorithms and machine learning model trained inside the Oracle database. So I will not wait for this to complete, but I will right away go into this into the database actions SQL to show you how it works, right? So basically, I have two models today that have been deployed here. Predictive maintenance, random forest AutoML. I will use this one, for example. And just before doing so, I will show you that I can show the install machine learning models here. So there is some views, and you can see that. So this one do exist. I can use them, 2 and 3, and those one are right now being trained, right? So this is continuously to run. So you can see interesting things while it's being computed. So going back on the SQL thing, I wanted just to show you some of the next code I will use for doing analytics, right, on my data. So what I will do here, I will leverage first. Remember, I want to work on the latest 10 seconds of data. So I will just use this kind of query, leveraging the SQL dot notation and remember, the collection is partition on this column, so I will use partition pruning, right? So if you look at the duration, it's pretty quick. Then I can build a view using, again, this CTE way and copying and pasting my previous query inside it. And then I can quickly retrieve every latest metrics that are JSON data, extracting and casting that to number, to real Oracle number or string, for example, and then taking only the latest 10 seconds of data while it's continuing to insert, right? Just here. Next, what you can do is, so I have some user mining models, probably much more now. Some have already been built behind the scene. And what I will do next is I will look at the data inside the JSON data. And you will see that there is in the device so the geolocation of the devices. So I will use this kind of this JSON value function to extract the geometry field, and I will translate that into some SDO geometry. So that's spatial Oracle data type. Let me come back. No. I will explain much more the query I'm using here. But typically what I'm doing here, I'm using the latest 10 seconds of data, and then I will use the prediction and prediction probability function to score in real time the data, right? So let's get started. Latest 10 seconds of data, extracting spatial information, and doing some prediction using a pre-existing model being deployed, right? So this gives you typically a 0 and 1. So this machine will fail according to the latest metrics. And this is the probability of failure, right? So this one will not fail, and this one will fail, right? So let's get back on much more here. So that's typically what I did, machine learning, model building, using them, using partition pruning, real-time analytics functions, using spatial data as well. And what you can see here is the duration, right? That's not very, very good. So if you look at the data here, as I said, inside each devices, we have the geolocation. That's just here. It doesn't want to print. Okay. Anyway, believe me. So what you can do to make that query above faster is to create a relational table where we just pre-compute my data. So here I'm building a new relational table this time, and I will just insert the data, and here I will just pre-compute every single value. So inserting my all the machines and the sensors, and you can see that we have now some spatial object here, right? I can access it with single field and interpretation kind of thing. So here, when I translate the previous query to use this one, what you can see is that it will go faster, right? And faster because it will be cached, and so you just get very, very efficient processing. So now, the last thing that I wanted to show you is that we probably want to have this dashboard right now. So again, Application Express is something that you get out of the box with any autonomous database. And so I can log on this portal to start building web applications in a low-code fashion. So let's go into the app builder thing. I did create a predictive maintenance dashboard, and I could create a page. I will not do that very right now, but I just want to show you how it is easy. Just the ID here. Our name, sorry. Dashboard draft. So you can just create web applications very quickly and efficiently. And if you hit play button, it's already there. You have authentication. you can manage CSS very efficiently. And so let's go on a previous page I just created for you. Don't get everywhere. What I just wanted to show you that you can consider some regions to have a lot of interesting charts or different components. What I did use is typically a map plugin, so that I can have interesting maps where I can just plug into it. Remember, or query exactly the same one. And then I will just wrap it into, again, a common table expression just to extract data to fill in properly the map. And when I just press the button here, so typically this application takes me maybe 20 minutes just to go and going slowly to build. And so what you can see here is that you have all the position of your real-time devices. So they are not moving, obviously, and we can display this very efficiently with a heat map where you can see that according to the probability of failure, you can have a different rendering of your map here. You can see the number of JSON metrics being loaded in real time. So here, probably I should focus my on-site engineers in Los Angeles or maybe San Francisco and so on. So basically the simulators is doing some controlled random modification of the sensor. And that's all for now. So that's what we mean by unique advantages and what you get, in fact, by just entering into this new you will have the slide here. I'm not reiterating the explanations, but I think you get it. One query, relational, spatial data, JSON data, and machine learning at the same time, and used for Apex dashboard. So I wanted to thank you for attending the session. Thank you, Bidat, for giving me the opportunity to talk. And now, if you want to have maybe some question, or if you have requirements, let's go for maybe a more.
Excellent. Thanks a lot.
Thanks.
Like, how long did it take you to build this demo, if I may ask? Because it has so many pieces, and you've been busy.
Honestly, I would say 3 days. 3 days just to invent the story and to see how to incorporate the different component of the architecture.
Yeah. No, it looks good. It's also the first time I do see it, and it's kind of resonating with our story in general that JSON it's a great data format. I mean, our team runs JSON, but the reality is that people need to combine different data models, and often they want to access, in some cases, they want to access JSON as a document, and in other cases, they just want to extract some fields from it. And this is where a relational view of the data is probably helpful. And then you do joins, or as you did, spatial extraction, and then you build with Apex. No, this is a good demo. Yeah, if there are any questions, I mean, everyone is muted, but you can write something in the chat. There was one question, if we could share some of this. I mean, we will certainly upload this video, make it accessible for you to review. Like, if people wanted to repeat what you did, like, I mean, are we doing like a workshop potentially, or?
Yeah, I think so. You know, the slide lab, and probably this will end up there. Right?
Yeah, so then it's not three days is to make the demo and like 30 days to turn it into a workshop. Yeah, so probably
less, but that's kind of French. Absolutely,
yeah. But yes, so sooner or later we will have something on workshop for people to try out. And right now, in limited availability, you really need to reach out to us to get access to it. So this Mongo API it's behind a hidden switch. So eventually, if we are generally available, there will be a switch. So if you log in into your cloud database, you would be able to just turn on a switch and it would be active. But right now, the UI for that switch that also shows you the connect string, it's hidden. but we have like back-end access to it. So please, if anyone is interested playing with this, just reach out to us, and we'll give you access. And we're then very interested in your feedback. What do you think works well? What do you think works not so well? Where should we do extensions? So this is probably an ongoing development for quite some time, but we're very much interested in customer feedback.
There is just maybe a question to answer. I will take that one, right?
Okay.
So yes, so it's a demo. So the code you have on GitHub is doing actually insert many, like you using bulk inserts, and updates. Bida just did that in his demo part.
Mm-hmm. Yeah, just right at the hour. Thanks, everyone. Yeah. And hope to talk to you soon again. Thanks, everyone.
Thanks a lot. Bye.
Bye.
Bye.